All right, today we are tackling one of the most fundamental and, let's be honest, powerful concepts in data: SQL joins. These are the absolute essential tools for taking scattered bits of information and weaving them into a single coherent picture.
I mean, think about any business, right? Your customer info is probably in one table, their orders are in a completely different one, and product details, yeah, that's somewhere else entirely. Your data is fragmented. So how do you answer a seemingly simple question like, hey, what are the names of the customers who bought our best-selling product? Well, the answer is joins.
So, here's our game plan for this explainer. First, we're going to cover the 4 essential joins you'll probably use every single day. Then we'll level up with some more advanced techniques for those trickier situations. After that, we'll take a quick peek under the hood to see how it all really works, and then we'll wrap it all up with a summary to make sure you've got this down cold.
Okay, let's start with the absolute essentials. I'm not kidding, these 4 joins will probably solve about 90% of the problems you're ever going to face. Think of this as your core toolkit.
First up, the inner join. This is your workhorse. It's the most common join by a long shot, and its job is super simple. It finds the perfect overlap, the intersection between 2 tables. It only gives you back rows that have a match in both tables. If there's no match, sorry, that row gets left behind.
And here's why that's so incredibly useful: precision. Let's say you have a table of all your customers and another table of all your orders. An inner join gives you only the customers who have actually bought something. It neatly filters out anyone who's just browsing or hasn't made a purchase yet.
Next up, the left join. What I really like about this visual is how it shows you where the focus is, on keeping that first or left table completely intact. A left join is basically saying, give me every single row from my left table, and go find any matches you can from the right one. And hey, if you can't find a match, no big deal. Just fill in those empty spots with null, which is just the database way of saying no value here. And this is a brilliant illustration of why that's so useful. Imagine you want a list of every employee and who their manager is. A left join makes sure all employees are on that list. Even the CEO, who doesn't report to anyone, will still show up. Their manager field will just be empty or null. The key is you don't lose anybody from that primary list.
Now, the right join is just the perfect mirror image of the left join. It's the exact same logic, just flipped. This time, it's the second or right table that stays complete. It guarantees that every single row from that right table is going to be in your result, with matches from the left table pulled in wherever they exist.
A great example is when you want to list all of your company's departments. A right join on the departments table will ensure every single one is shown, even if it's a brand new department with no employees assigned to it yet. It's perfect for finding these kinds of orphaned records.
But what if you don't want to leave anyone out from either side? That's where the full outer join comes in. You can think of it as the ultimate mashup of a left and a right join. You get all the matches in the middle, plus all the unique rows from the left table and all the unique rows from the right. It's the full, unedited story of both tables combined.
This makes it an incredible tool for things like data reconciliation. Say you need to compare this month's sales data with last month's. A full outer join will instantly show you what's the same, what's brand new, and what's missing. It's fantastic.
All right, with the fundamentals covered, let's gear up and grab some specialist power tools. These are the advanced joins you'll pull out of the toolbox to solve those very specific and often tricky problems.
Now for our really interesting one, the anti-join. Its entire purpose is to find what isn't there. It's subtractive. It takes your first table and then it carves out anything that also exists in the second table. What you're left with are only the records that are exclusive to that first table.
And this is where data turns into real-world strategy. An anti-join between your customers and your orders tables gives you that golden list, all the people who signed up but have never ever bought a single thing. That's not just data, that's a targeted marketing campaign just waiting to happen.
Okay, let's switch gears to something totally different, the cross join. This one's a bit of a wild card. It completely ignores any kind of matching keys. Instead, it creates every possible combination of rows between the 2 tables, what's technically called a Cartesian product. It takes every row from the first table and pairs it up with every single row from the second.
Now, what's really important to see here is the multiplicative effect. If you join a table of 10 t-shirt colors with a table of 5 sizes, you don't get 15 rows. You get 10 times 5 for a total of 50 unique combinations. So you got to use this one with care because your row count can absolutely explode in a hurry. So when would you ever want this? Well, the perfect use case is for generating things like a master product catalog. You've got your sizes, you've got your colors, you've got your styles. A cross-join will build that comprehensive list of every possible item you could ever stock.
The self-join is a really clever trick. You're literally joining a table to itself. And you might be wondering, how is that even possible? Well, you do it by giving the table two different temporary nicknames, or aliases. This tricks the database into thinking it's looking at two separate tables, which then lets you compare rows and find relationships all within that one single dataset.
And this right here is the classic example, organizational hierarchies. You have one employees table, right? And inside that table, there's a manager ID column that points back to another employee's ID. A self-join is exactly how you connect those rows to build a clear employee-to-manager map. Okay, so we've covered the what. Now let's pop the hood for a minute and look at the how. You should think of these next concepts not really as new types of joins, but more like the rules of the game that actually govern all the joins we've just learned. This distinction is really simple, but it's crucial. Almost everything we've talked about is an equi join because it uses an equal sign to find an exact match. A non-equi join is different. It uses other operators like greater than or less than or between. For example, you could join an employee's salary to a tax table to find which tax bracket their salary falls within. It's not an exact match, it's a match based on a range. Now, a quick but very, very important warning about something called a natural join. It tries to be smart by automatically joining tables on any columns that happen to have the same name. But as the source material warns us, this is basically a trap. You might have two different columns named date that mean completely different things, and the join will give you garbage results. The key takeaway here is simple. Always be explicit. Always write out your own join conditions.
And that brings us to our grand summary. Let's just quickly recap the big ideas. We started with the inner join for finding those perfect matches. We used left and right joins to keep one of our tables complete. We saw how the full outer join shows you the whole picture and how the awesome anti-join helps you find what's missing. This table right here is your cheat sheet, the complete toolkit all in one place.
So there you have it, the 10 joins that really unlock the true potential of your data. The power isn't just in knowing the syntax, right? It's about understanding which tool to grab to answer the right question. You now have the complete toolkit to connect any pieces of data you want.